Yeah, very good morning to all. So today let us discuss about tidal energy conversion. So one among the energy resources available from ocean for sustainable electrical generation is from tidal energy. So when you see that tidal energy is the form of hydropower using water to create energy. Tidal energy converts energy obtained from the tidal movement into electric power. So the up and down motion of the water or the forward and reverse motion of your ocean water, with the help we are able to generate power. The total power was first contributed in 1970 during the oil crisis, when there was an initial emphasis on development of alternate energy resources. Okay. The causes of tides. What causes tide? So tide occurs due to gravitational pull of the moon, gravitational pull of the sun, and earth rotation. The tides refers to the rise and fall of our ocean surface. It is caused by the attractive force of moon, sun, gravitational field, as well as centrifugal force due to earth's spin. So moon, although much smaller than sun, but it is very closer to earth. So now gravitational force decreases rapidly as the distance between the two masses is widened. So you will have less compared to moon sun effect. Thus moon gravity has a larger effect on tides than the sun. In fact, sun effect is only about half of that of moon. Even though size of the sun is very big, but what to say, sun is far from moon and moon is very close to earth. So due to moon we have a tidal mean crust. So you can see here the size of the moon is very small compared to earth and sun. So diameter is around 3476 kilometer for moon, whereas it is 12,756 kilometer is earth, and which is around 1392, that is approximately 13,92,000 kilometer is the dia of the sun. So this is a very big in size. It is like in basketball size, and ours is like a marble. When you see from moon, it will be like a glass marble. Okay, so this is about the size of three different planets. Now when you see earth is here, moon is revolving around the earth, and since moon's mass, there will be a pull of from your moon, as well as you have pull up from the sun, where but this is will be less compared to this. And when this, we all know moon go around every day the earth once. So when it comes to this part side, both moon as well as sun will have in same direction of pull. So just we will see that moon and earth revolves about each other in the space, but since the mass of the earth is nearly 100 times greater than moon, the mass than moon mass, the moon motion is more apparent. The center of the revolution is O. So let us take this is earth and this is the center of revolution. Then we have ml is equal to m dash l dash. M dash is earth, m is moon, l is from the center of E to moon, we call it total distance, which is equal to L plus L dash. So L plus L dash is also the diameter of the attractive force between the earth and the moon. So generation of tidal energy, the power is taken from earth oceanic tides. The tidal force are a periodic variation in gravitational attraction excited by the celestial bodies. Due to the strong attraction of moon ocean, in the water level is created, causing a temporary increase in sea level. The tidal steam generation make use of kinetic energy of the moving water to the power turbine, and a similar way to wind turbine that uses wind as a power for rotating the turbine. So we have three types of tidal energy conversion method. One is tidal barrage system, then tidal steam turbine, and tidal lagoon system. So see, let us see one by one. So first one, tidal barrage system is a large dam-like structure built across the bay of harness the tidal energy by managing water flow through the turbine. It operates by tapping water due to high tides and release during low tide and vice versa. Okay, so initially when high tide is there, the water will cross this side and you will store it here. So then again this is released and this water will go back. So once again high tide water will be collected and will be allowed. So when the water moves this side, this turbines will rotate and try to generate energy. So this part alone I have zoomed here and I have shown that you will have a barrage here, and it is like a structure. So water from high level will flow through water to the lower level. Then second one is tidal steam turbines. Tidal steam turbines are submerged renewable energy device that convert the kinetic energy of tidal current into electrical using underwater rotors, similar to the wind turbines. Because seawater is roughly 800 times denser than air, these turbines can generate significant power even in slow flow velocity. So this is how the structure will be. So you can see here this setup separately we might have seen in wind turbine, which is rotating on air, whereas similar structure we develop and we keep inside the water. So the flow of water will make it rotate. Even if the flow of water is very slow also, we will get an effective or efficient will rotate because the velocity or the density of the water is more. Then the third one, tidal lagoon system. This is similar to the first one. Only thing is that is naturally built. This is totally artificially built. It is an artificial enclosed structure built along the coastal line to generate renewable energy from rise and fall of the tide. By using turbine with the barriers, it capture water at high tide and release at low tide, creating a constant, periodicable and low impact energy resource with the potential source. So this is how. So where we artificially build. So artificially we build like this structure, and bottom we will have a opening for water to flow. That part we shown here. Okay, so this is where the people walk. This is on the top and this is on the side view. So now you can see here we will allow water and we will make the water to leave, which is causing this turbine blades to rotate. Then advantage of tidal power, 100% energy is periodicability, so which means it will not stop on any particular day. On all the days we have high density than air, so water generated density provides much more energy potential per unit volume than air because it is high density. Then 120 years equipment lifespan. So long lasting infrastructure with multi-decade operational lifetime. So even if you put solar, your solar panel efficiency will be for 10 years and it will start to degrade, but this is not so. So you will have more lifespan. Okay, reliable grid integration is possible. Space and efficiency. See, space, we have very huge space of ocean, so we can have an more we can place. Okay, proven longevity. So when you see the advantages and limitations, first is initial high cost. Then you should have a geographic constraints. I cannot build everywhere. I can build only near the coastal. Then intermediate generation. So during high tide you have to store and you have to release. So during some part I will have and some part I will not have my generation. And then one maintenance challenge is saltwater exposure, so cause the equipment corrosion, and deterioration significantly increase the operational maintenance costs. So environmental impact, emission effect, marine life mitigation. So like when there is any fish or any other ocean living organism that may get disturbed by this placing of blades. Global market and major projects. So in India, till now we have not installed any tidal. We have started in two places, but due to financial reason and we have stopped it. So till now we doesn't have any tidal power plant in India. Whereas we have in South Korea, France, United Kingdom, and then Japan and United States. So in which major contribution is from South Korea. They have 254 megawatt of tidal power plant. Market projection: the global wave and tidal energy market expected to reach 4.07 million by the year 35, growing at 9.2 CAGR from 2026 to 35. Key innovation includes hybrid renewable integration, AI-driven optimization, wave-powered desalination, and offshore hydrogen production. So by various way, we are going to go for production of power from tidal. So in near future, we will move towards tidal energy. Just we will have a small animation video.
Tidal power. Tidal power is a form of hydropower that converts the energy from the natural rise and fall of the tides into electricity. Tides are caused by the combined effects of gravitational forces exerted by the moon, the sun, and the rotation of the earth. Tidal plants can only be installed along coastlines. Coastlines often experience 2 high tides and 2 low tides on a daily basis. The difference in water levels must be at least 5 meters high to produce electricity. Tidal electricity can be created from several technologies, the main ones being tidal barrages, tidal fences, and tidal turbines. Tidal barrages are the most efficient tidal energy sources. A tidal barrage is a dam that utilizes the potential energy generated by the change in height between high and low tides. This energy turns a turbine or compresses air, which in turn creates electricity. Tidal fences are turbines that operate like giant turnstiles, whereas tidal turbines are similar to wind turbines, only underwater. In both cases, electricity is generated when the mechanical energy of tidal currents turns turbines connected to a generator. The generator produces electricity. Ocean currents generate relatively more energy than air currents because ocean water is 832 times more dense than air and therefore applies greater force on the turbines. Tidal power is easy to install and renewable, having no direct greenhouse gas emissions and a low environmental impact. Because the ocean's tidal patterns are well understood, tidal energy is a very predictable energy source, making it highly attractive for electrical grid management. This sets it apart from other renewables that can be more unpredictable. However, adoption of tidal technologies has been slow, and so far the amount of power generated using tidal power plants is very small. This is due largely to the very specific site requirements necessary to produce tidal electricity. Additionally, tide cycles do not always match the daily consumption patterns of electricity and therefore do not provide sufficient capacity to satisfy demand. That's tidal power. Tidal power. Tidal power.
Thank you for patiently listening. Thank you so much.